Hello guys, still on WACC, and this will be the third question I'm going to be solving on cost of capital. This one is another WACC question. If you look at this AMH core, it has different types of capital, and like I said in my previous video, I love questions like this because it gives opportunity to revise cost of debt, cost of equity, and putting it together, you can determine what WACC is. And remember, what is WACC? WACC is just cost of capital when you have combination of liability and equity as source of capital, right? So once you have the combination of these two items, then your cost of capital has to be weighted and cannot just be cost of equity alone or cost of debt alone, but you have to weight both cost of equity and cost of debt to get your weighted average cost of capital. And I've simplified it for you. I said we're going to be using 5 steps approach, which we used in the previous questions. The same 5 steps we're going to apply today. And remember, the first step, which is step 1, is to identify the sources of capital in the question. So if you look at this question now, what are the sources of capital here? So step 1, what are the sources of capital? If we check it, we'll see that there's equity. So we have equity. What else do we have? We have preference shares. We have redeemable bonds. And lastly, we have bank loan. You can see there, we have bank loan. So this question has 4 types of capital. So we've passed step 1. Step 2 now is to calculate the proportion, remember? So we need to get the percentage proportion of each type of capital that we have. We need to get the proportion for each of them. So let's look at it. Let's start with equity. So this is step 2. This is step 1. We've done that. So let's work out step 2 now. First of all, remember, we need to get the volume of each capital. Then we'll get the total. Then we'll get the proportion. So let's get the volume of equity now. So equity, what is the volume of equity? So remember, our focus is always to calculate the market-based weighted average cost of capital, except when the question asks us for book value based. That is when we will not be using pricing and we'll be using the book value. Yeah, because if we want to do a book value weighted average of cost of capital here, equity will be reserves and the ordinary shares, which will be addition of 18 and 4. So book value of equity is, book value of equity would have been 22, as you can see here. But we're not using book value WACC. We want to calculate weighted average cost of capital in market value terms. So in the questions, they give us the price of the share. You can see the ordinary shares is 4.7. So the price of the share is 4.7. Then the question is, how many shares do we have in this question? Equity, ordinary shares. Nominal value is 50 cents, and that gives a book value of share capital of $4 million. So if one share is valued at $0.5, that's 50 cents. Yeah, and the total value of this share is 4 million. That means the number of shares that we have will be 4 times 1, remember, divided by 0.5. So it means that we have 8 million shares. So that's 4.7 times 8 million, and that gives us the value of, put on calculator, that gives us 4.7 times 8, let's see, that's $37.6 million. So that is the value of equity. We need to get the value of preference shares, get the value of redeemable bonds, value of bank loans as well. So let's get the value of preference shares now. So for preference shares, they give us the price of preference shares. Let's see. Okay, the preference shares, if you look at this last paragraph, the preference shares of AMH Co. are not redeemable and have an ex-div market value of 40 cents per share. So that's $0.4. Then what is the number of preference shares? How many preference shares do we have? Let's find out from the questions. The preference share has nominal value of 1 and the book value is $3 million. So that means there are 3 million shares. Because if one share is $1 and the total value is 3 million, that's pretty straightforward. So that is 0.4 times 3 million, and that will give us 1.2 million. That is 1.2 million. That's preference shares. The third one is redeemable bonds. What's the price of redeemable bonds? The question says here that the 7% redeemable bonds are redeemable at 5% premium. Nominal value is $100, which we always expect. That is the face value of any bond, with an ex-interest market price of 104.5. So we know the market price to be 104.5. But how many bonds do we have? Remember, the face value of the bond is $100 per bond, and that is the way it's being recorded in the book. So if you look at this, you see we have 3 million value. If it's 3 million value and one bond is $100, how many bonds do we have? That is straightforward. That is just 30,000 bonds. Yeah, and I can work it out for you just to, in case you feel confused. Let me show you. So we say one bond is equals to $100. Yeah. Then 3 million values will be how many bonds? That is just to say 3 million divided by 100. So what do you have? You have 30,000 bonds. So that's 30,000 bonds that we have. So that's multiplied by 30,000. And that gives a value of, so the redeemable bond has value of 104.5 multiplied by 30,000. And that is 3.135 million. That's the value of the redeemable bonds. That is not all. We still have the fourth one, which is a bank loan. Remember I said in my last video, bank loan doesn't have market value. You always assume the book value of the bank loan is the same thing as the market value. So that means bank loan will always be $1 million. Now the total value of capital, so the total capital that we're talking about here will be equals to the 1 million of bank loan plus 3.135 of redeemable bonds plus 1.2 million preference shares plus the equity 37.6, and if we add all of that together, we have 37.6 plus 1.2 plus 3.135 plus 1, and that gives 42.94 million. So this is the total capital that we have. So to get a proportion for each item, we divide the value by the total. So for equity, the proportion of equity will be the volume of equity, which is 37.6, divided by the total, 42.94, and that gives us 27.6 divided by that gives us 87.5%. Then we have the next one is preference shares, which goes to 1.2 divided by 2.2 divided by 42.94. That gives us 1.2 divided by 42.94 times 100. That gives 2.79%. Then the next one is the redeemable bond. Has value of 3.135, then divided by 42.94 as well. Let's see what that comes to. 3.135 divided by 42.94. So this times 100, 7.3%. And the last one is a bank loan. This 1 divided by 42.94. Let's do that. 1 divided by 42.94. And that gives times 100, 2.3%. Like I said, if you had all these percentages together, you should have 100% to test whether there is a mistake. So let's do that. I'll quickly check. Yes. So this gives 99.9%, which is approximately 100%. So that means this is correct. If you add all of this together, it gives 99.9%. So that's a good check. So now we can plug that into our table. So we have 87.5. We have 2.79, so we can make that 2.8%. 7.3 and 2.3. 7.3 and 2.3. So we have the proportion. Now the step 3 is calculate the cost of each capital, which is where the kind of revision of what cost of capital is. The easiest one is a bank loan. Let's quickly do step 3. So let's start with the bank loan, the easiest one, which is just interest into 1 minus t. This bank loan is paying interest at what rate? Let's see. It's stated here that the bank loan has a variable interest rate that has averaged 4% per year in recent years. So we already know that the bank loan interest is 4%. So that's 4% into 1 minus tax is given at 30%. So that equals to 4% into bracket 70%. And that will give 2.8%. So bank loan, we can fix that quickly. The cost of bank loan is 2.8%. So the next one, let's go for redeemable bonds now, which is the most difficult one, from the easiest to the most difficult. Redeemable bonds. How do you calculate the cost of redeemable bonds? Remember, for redeemable bond, the cost of redeemable bonds is simply IRR. So here we need to calculate IRR. And IRR is equals to your lower rate. Remember the formula? So NPV at lower rate divided by NPV at lower rate minus NPV at higher rate into bracket higher rate minus lower rate. Yeah. Remember, do this first. Yeah. So which means we need 2 rates, and like I always said, stick to 5% and 10%, just to make sure you're not changing so many things, and it's easier to move with it. So let's plot our cash flow using our template. So we're going to plot the years. Yeah. We're going to have year 0. And this bond is, what duration is this bond? Redeemable to the nominal value and have an exchange rate per bond. The bank loan has a variable. Let's see. Here they give us in the question here. So the 7% bond redeemable after 6 years. So it's going to pay coupon for 6 years. Then after 6 years, it's going to be redeemed. And it's going to be redeemed at 5% premium. So which means it's not redeemable at par. is redeemable at 5% premium. 5% premium means you are going to get additional 5% on par. So 5% on par is 5%. So if you say 5% on par, par is always 100. So 5% of par is equals to 5. So if you are getting 5 premium, it means that you're going to get that in addition to the 100 of par. So in total, you get 105 at redemption date. So that's the cash flow at redemption date. And if you check how much is the bond today, which is the price we're going to buy it for, the market value of the bond is 104.5. Yeah, which is stated here. You can see 104.5. Right? So we're going to buy it at 104.5 today. Then we're going to make get a coupon at 7%. That's the interest rate on the bond. So the bond will pay interest at 7%. 7% of 100 is 7. However, because there's 30% tax, you're not going to get the whole of that 7. So you're only going to get 7 into bracket 1 minus 30%, because you're going to pay that tax at 30%. So you're going to get 4.9 as a net cash flow. So the net cash flow on that bond every year is 4.9. So that's cash flow. Then we need to get our discount factor. And like I always say, discount factor today, year 0, will always be 1. Then 1 to 6 means there's a cash flows for more than 1 year. And once you have constant cash flows for more than 1 year, it's better you just make use of an annuity table to make life easy for you. So let's go discount factor at 5%. This time our annuity table for 6 years at 5% sticks to 5.076. And 5% at 6, but this time around, we're going to be using present value table because this is a single cash flow, one cash flow. So we're going to use at 6 years, 5% at 0.746. And with that, we can get our present value at 5% discount rate. So this remains minus 104.5. Then 4.9 times 5.076, that gives 24.87. 105 multiplied by 0.746 gives 78.33. And if you add everything together, you have minus 1.3. So that is NPV at lower rate. But now we need to get discount factor at 10% so that we can get our NPV at higher rate. This remains 1 because it's today. But go to annuity table, 6 at 10%, that's 4.355. That's this one, 4.355. So 4.355. Excuse me. Then we go to present value table, single cash flow, 6 years at 10%. That's 0.564. And with this, we can get our present value at the higher rate. So this remains minus 104.15. Now we have 4.355 multiplied by 4.9. And that gives 21.34 and 0.564 multiplied by 105. That gives 59.22. So if we add everything together, 559.22 plus 21.34 minus 104.5. That gives minus 23.94. So we have, this is NPV at higher rate. Now we need to plug this data into our popular formula, this formula. That's what I'm going to do right now. So our lower rate is 5%. plus NL, which is minus 1.3 divided by minus 1.3 minus into bracket minus 23.94, then multiply by 10% minus 5%. So let's deal with this part first. All right, so we know that 5% is constant plus minus 1.3, one step at a time, divided by 1.3 minus 1.3, then plus 23.94. That gives divided by 22.94. Well, 22.94, then multiply by 5%. So we'll do 1.3 divided by 22.94. That gives still 5%. Multiply by minus 0.05. Multiply by 5%. That equals to 5%. This should be plus, sorry. 2 plus, then multiply by 5%. That gives 0.28% negative. That's plus 5. That gives 4.71%. So we have IRR at 4.71%. So we have our cost of redeemable bonds to be 4.71%. Then we'll go to our table and we'll plug that in there, 4.71. So redeemable bond, 4.7%. Then preference shares. Preference shares is a popular formula, which is one of the easiest formula for cost of capital. It's strictly just the interest, or you call it dividend. It doesn't have tax implication, divided by the X interest price. So this preference shares, we go to the question. This preference share is paying interest at 4%. So if you're going to pay interest at 4%, remember it's always 4% of the nominal value. So which means going to pay interest at, so interest of this preference shares is equals to 4% multiplied by nominal value, which is $1. And so if you do 4 times 1 divided by 100, that is your interest amount, which is equals to 0.04. So it's going to pay interest of 0.04. What is the X interest price? We're given X interest price of this preference share to be equals to, we're given somewhere, remember preference shares, yeah? Now do we want to have X dividend market price of 40 cents. So we're given to be 40 cents. And 40 cents is $0.4. So that's $0.4. So get preference shares equals to 0.04 divided by 0.4. And if you do that, you have exactly what we call 10%. Pretty easy. So cost of preference share, we put it here to be 10%. And for equity, the last one now. So cost of equity, KE. Remember, there are always two models for cost of equity. I told you can use dividend model or you can use capping. depending on the information available. Looking at this question that we don't have any information on beta, so we already have an indication that we're going to be using dividend model because we have dividend information has been given. And we can see that dividend is not constant. Look at this paragraph. The ordinary shares of AMH have an ex-div market price of 0.7 per share and an ordinary dividend of 36.3 cents per share has just been paid. So additional dividend of 36.3 has just been paid, but they gave us the historical payment of dividend, so which means they don't pay the same dividend every year. So 2008 they paid 30.9, 2009 they paid 32.2, 2010 they paid 33.6, 2011 they paid 35, and 2012 now they paid 36.3. So which means the dividend is growing. In that case, we will need to use a dividend growing model, which says that the cost of equity is equal to the current dividend that was just paid, 1 plus G, divided by the ex-div price, and plus G. I know you still remember this formula very well, right? So remember this ex-div price. So, but we don't have G in this question. We have the dividend that has just been paid. The dividend that has just been paid is 36.3. Did not. We have that. Yeah. This is what has just been paid. Did not. So we have this. We don't have G. Ex-div price. Do we have that? We actually do, because they gave us to be 4.7 in the question. You can see the ex-div price of this share is 4.7. So that has been given. So the only thing we don't have here is G. So we need to get G. And remember, there are two ways of getting G. There's an average method, and there is Gordon's growth method. Yeah, which says that retention times return is your growth rate. And this one rather will use the future value formula, which it says that FV equals to PV into 1 plus R raised to power N. Yeah, that's the application of that average method. So if you look at this question, we don't have retention information, we don't have return information. So we cannot use Gordon growth method. We need to use average method. So look at average method. Look at like this. Future value is equal to present value into 1 plus R raised to power N. Because this formula is very important. It's the same formula that has been used to determine that average formula, which I don't advise you start memorizing, because once you know this formula, you don't have to memorize that formula. This is what you need to know. So your future value is the most recent value, which is 36.3. That is the most recent value of dividend that we know, 36.3. The present value is the old value. So the oldest value here is 30.9, which is 2008 dividend. So 30.9. Then 1 plus R. R is the G that we want to calculate, right? And N is the number of years that we have grown from 2008 to 2012. So which means we move from 8 to 9, 1, 9 to 10, 2, 10 to 11, 3, and 11 to 12, 4. So this is 1 year, 2 years, 3 years, 4 years. So this dividend has grown for 4 years. I like to break it down like this so that you don't ever make mistake. Because some students will just look at, I have 2008, I have 2009, I have 2010, I have 2011, I have 2012. 1, 2, 3, 4, 5. And they say, oh, N is equals to 5. That is wrong. N is not equals to 5. The best thing is you are moved from 2008 to 2012. Your number of years of growth is 2012 minus 2008, which is equals to 4 years. And that is what I've broken down here, that you grow from 8 to 2009, from 2009 to 2010. Yeah, like that, you see that it's truly 4 years of growth. So that is raised to power 4. As simple as it is, I've marked student answer script and they've missed this type of question just by using the wrong number of years. So 1 plus G raised to power 4 equals to 36.3 divided by 30.9. And that equals to what? 36.3 divided by 30.9. That is 1.18. So this is 1.18. So 1 plus g will equals to 4th root of 1.18. Or you can say equals to 1.18 all raised to power 1 over 4. I think this is easier to do on Excel, especially if you're using Excel. So you can do it like this. It's the same thing you're going to get. So 1 plus g equals to 1.18 raised to power 1 over 4 is the same as 0.25. So that equals to 1.041. Therefore, g equals to 1.041 minus 1. And g equals to 0.041. And if you convert to percentage, that means you multiply by 100, and that becomes 4.1%. So that is g. So now that we know our g, we can go to our KE formula that says that d naught into bracket 1 plus g divided by x div price plus g. So d naught is 36.3 cents, which is 0.363. Let's work in dollars so that we're consistent. And 1 plus 4.1% divided by $4.7, which is the price of the shares, plus 4.1%. Remember, plus G. So that equals to 4.1% plus 1 multiplied by 0.363. That's 0.3, so that equals to 0.378 divided by 4.7 plus 4.1%. So 0.378 divided by 4.7, that is 0.08 plus, let's take this one to numbers, because you can't add number to percentage. Is that you're adding percentage to percentage, or you're adding numbers with numbers? So 0.08 is something as 8%, and plus 4.1% is something as 0.041. Right. So if you do it this way, then it becomes 0.041 becomes 0.121, and that is the same thing as 12.1%. So that's our cost of equity, 12.1%. So let's put that in there as well. Cost of equity, 12.1%. And step 4. Remember, you need to be comfortable with this. Once you are comfortable with these steps, then you will be able to do it very fast without mistake. Yeah, and you get your full marks. Yeah, so step 4 is to multiply this and step 3. So step 2 times step 3, so which is pretty easy now. So 12.1 multiplied by 0.875, and that gives 10.6. Then you have 10% as well, which is 0.1 multiplied by 2.8. You have 0.28%. Then 4.7 multiplied by 7.3%. That's 0.34%, and likewise 2.8% times 0.3, and that gives us 0.06%. And step 5 is the addition of everything, which is adding all of this together. So that's 0.06 plus 0.34 plus 0.28 plus 10.6. And that gives 11.3%. So our WACC here is 11.3%. And that is it with AMH. So WACC is 11.3%. And I want to believe that it's looking simple enough. Yeah, it's longer because you're learning. Yeah, I could have rushed into just putting down formula and lumping it up, but that's not the essence of doing these videos. I need to be very comfortable. I want to be 100% confident that when you say WACC questions, you are excited and not afraid. See you in the next video where I'll be looking at asset beta and equity beta and how these affect our investment decisions have been taken. Yeah, but until then, please remember, always like this video, put a comment, refer it to your friends, and if you have questions, don't ever hesitate to come to me. I'm always here to help you. I'm happy to support. Thank you. Bye.